Magnets and magnetic field. You must have experienced different forms of magnets, such as horseshoe magnets, bar magnets, cylindrical magnets, and plane magnets, which are usually used to stick things on the refrigerator. All types of magnets attract all objects that contain iron, such as paper clips and nails. Things are strongly attracted to the ends of the magnet, and these ends are called the poles. The magnet has two poles, one of which is called the North Pole, and the other is called the South Pole. Although magnets come in many different shapes and sizes, different magnetic poles attract, and similar poles repel each other. One of the facts about magnets is that no matter how many times a permanent magnet is cut, each piece always has a North Pole and a South Pole. Thus, magnetic poles always occur in pairs. The magnetic properties of many materials are explained in terms of a model, in which an electron is said to spin on its axis. The spinning electron represents a charge that is in motion. In atoms containing many electrons, the electrons usually pair up with their spins opposite each other, causing their field to cancel each other. For this reason, most substances, such as wood and plastic, are not magnetic. However, in materials such as iron, cobalt, and nickel, the magnetic field produced by the electron spins does not cancel completely. Such materials are said to be ferromagnetic. In ferromagnetic materials, strong coupling occurs between neighboring atoms to form large groups of atoms whose net spins are aligned. These groups are called magnetic domains. In an unmagnetized substance, the domains are randomly oriented. When external magnetic field is applied, the orientation of the magnetic field of each domain may change slightly to more closely align with the external magnetic field, or the domain that are already aligned with the external field may grow at the expense of the other domains. This alignment enhances the applied magnetic field. Unmagnetized piece of iron can become a permanent magnet by being stroked with a permanent magnet. Magnetism can be induced by other means as well. For example, if a piece of unmagnetized iron is placed near a strong permanent magnet, the piece of iron will eventually become magnetized. The process can be reversed either by heating and cooling the iron or by hammering, because these actions cause the magnetic domains to jiggle and lose their alignment. A magnetic piece of material is classified as magnetically hard or soft, depending on the extent to which it retains its magnetism. Soft magnetic materials such as iron are easily magnetized, but also tend to lose their magnetism easily. In hard magnetic materials, domain alignment persists after the external magnetic field is removed. The result is permanent magnet.